Hello everyone, and welcome to another episode of Man Cave Coding with me, Craig Gilchrist. So this one, way back in June, I did a WebGL tutorial which was hosting Unity WebGL in Angular and ASP.NET Core, where I went through how to build, really stripped down a build to work well on mobile and on desktop browsers, and some of the trials and tribulations of getting there. This is a follow-up to that tutorial where I said it might be a good idea, I think right at the end of this blog I said it might be a good idea to, if anyone was interested, that it would be a good another good tutorial as if we did some two-way communications. So this one's a really quick one where I'll build on this tutorial. So this was the original. This is an Angular build inside, a Unity build, WebGL build inside an Angular.NET Core hosted web application. This is the next iteration. So we've got a simple sort of character who has some animations. We've got a control which has the feedback for the current animation that's playing. So if I hit start, you'll see the animation is backflip, uppercut. Some two-way controls, so starting and stopping the animation. Camera rotation, starting and stopping that, and setting the camera distance. So that is what we're going to be building. Like I said, it should be a really short tutorial. If you haven't already follow along the first tutorial. So this one builds on the code base from there. If you want the code base from this, if you go to github.com/Craig Gilchrist, the tutorial should be, the repo should be under the Angular Unity Net Core. So I'll post a link in the video as well. Okay, so first things first, let's have a quick look over at Unity. So I just wanted to go through a couple of things in the Unity build. I'm not sure if that's zoomed in well enough. Let's zoom in a little bit into this. So what we've got is a really simple animator controller, which has just, what I've done is I've gone onto Mixamo, so mixamo.com. I've used one of their default characters and downloaded a load of their test animations as well. So what we've got is the default animation is idle, which is this. If I hit play, you should see it's just this idle animation. And what we've got are two parameters, trigger parameters for start animation and stop animation. And that is a property of this substate. So if I click on this, sorry, not any state. So the condition for this, excuse me, the condition to go from any state to the very first animation is that the start animating trigger has been called, and beyond that it just goes around in a loop. And we've got a second state where the state transition, where we have from any state back to idle if the stop animating has been called. Okay, so that's pretty much it. If I hit start now, pop on this Douglas T-pose and I trigger the start animating, you'll see it'll start to go into this loop. Okay, and so on and so forth, and it'll continue on that loop and forever until the stop animating trigger has been called, and then that will go back to idle. Okay, so this simple animator controller, a model and animations downloaded from mixamo.com, and let's have a quick look at a couple of the other pieces of code. So we've got the main camera. Well, let's have a look at the main camera. So the main camera, I have a really simple script I've created called camera control. Let's have a look at that now. So the camera control has a couple of fields. So the distance, which is the distance from Douglas, our 3D model. The target, which is set to, I believe, Douglas's head. Yep, which is Douglas's head, which you can see here. Go to the scene and you can see that. Yep. And yeah, a bool to represent whether the camera is rotating or not. So that's it, really. Distance, the target, and whether or not it's rotating. So actually, we've got to maintain distance. We don't really need this maintain distance. I don't think it's used for anything. Let's get rid of it. I don't think we really need the start either because we're not doing anything with it. Okay, so we've just got a really simple if statement. So if rotating, then we will rotate around the target's transform position. Just at a sort of a set speed, and we will look at the target. Otherwise, if we're not rotating around, what I do is I move the camera towards the position, which will be the forward position of the target multiplied by the distance. So yeah, and again look at the target. So if I play that now, and you'll be able to see, I've actually got a couple of keyboard shortcuts to it, I believe. So if I press, nope, not that one. If I press 2, you can see the rotation occurs. So that will always just rotate around. But if I do it again, this is no longer rotating. So it tries to stay, I think at the default distance is 2 meters. So if I go to main camera, yeah, you'll see 2 meters. If I push that up to say, you'll see it just slowly moves towards that position. So if I were to rotate around now and reduce the distance, you'll see it'll try, well, it does it quickly. And then it sort of sets itself back to the position more slowly. So that's it. That's the camera control. Not a lot to that code. Secondly, we have an animator, a script that I've called animator events. Let's have a quick look at that. So this one is a little more complex. So what it does is it calls a method called animation state change every time the animator clip changes. So as it goes through this cycle, if I go back to the animator, as it goes through this cycle, an event is called, let me just stick oh, there is already a debug log. Let me press play. You see here it says animation changed idle. If I click on Douglas and I start animating, you'll see that says now backflip, uppercut, and then Gangnam is next. You see, so the it logs that event, but it also sends it to this animation state changed. So in order to call JavaScript functionality from within your Unity build, you need a file in the assets folder, in the plugins folder, that ends in the file extension .jslib. So I've got one here called browser interactions, and it needs to take this format. So merge into library manager.library, and then the name of each of your methods. So this method, if I open up the animation events again, this method corresponds to, just collapse that, the name of the method. So we've got animation state change, and we've got a static extern void of animation state change. So once you decorate it with the DLL import and the DLL name of underscore internal, that function becomes available to you. So when the function's called within C# code or JavaScript, if you're using JavaScript for your Unity programming language, the method that has been imported from the JSLib is called. So I'm passing in the current clip name to this animation state change, which will in turn call this JavaScript function. Now what the JavaScript function does is it checks to see if the window has a method, has a function called animation change listener, and if it does, then it calls that method by what you get passed is actually a pointer. So there are some helper methods. This particular helper method is called pointer stringify, and it puts it back, it takes the pointer, the string pointer, and gives you the original string value back. So yeah, what we would need to do then in Unity is wire up that event, wire up that function on the window to do something with that in one of our Angular controllers. Okay, so pretty straightforward. What's happening is this script gets the animator. So if I look at the implementation here, if I go back to Douglas, you can see the animator target is Douglas himself. So that's the only field. And we're keeping a reference to the current clip name. So the current clip name to start with is nothing, is null. And then we are, every time that changes, every time the clip name is different to what we know, we get the latest clip name and we call our JavaScript function, which we've imported with the JSLibs. So, yeah, quick recap: add a file with the extension .jslib to the plugin folder of the plugins folder of the assets directory, and that should give you methods that you can call, JavaScript methods that you can call in C#. Yeah, and then import the names of the methods that you want with the static extern void decorated with the DLL import attribute. Okay, so that's the second file. So we've got the camera control, which literally does some panning, maintains distance from the target, and we've got animator events, which calls out the name of the current animation. So if we have a quick look at our build, that's the value here. So this, we just zoom in a little bit so we can see nice and big. Yeah, so we've got this. If I start the animation here, you'll see it's this backflip uppercut. Okay. So the final piece of code that we have here is I've got just a simple game object, and I've called the script scene control, and that's just our control that binds everything together. So if we have a quick look at that, let me close this now. We have these are just some test methods that I was using to test earlier, but we have a couple of simple methods. We have start stop rotating, which references our camera control and just sets the rotating value to, it switches the rotating value. So if it's true, it switches it to false. If it's false, it switches it back to true. Start stop animation, which checks the animator current clip. If the clip isn't idle, then it fires the trigger start animating. So just a quick recap again. That's this trigger here. and if it's already animating, so if the clip name isn't idle, then it calls stop animating. So yeah, two sort of simple methods for the camera rotation and the animation. And then finally another one which calls set distance, which sets the distance value on the camera control. Okay, so there's a couple of references in that scene control. So we have our animator again and the camera control script. And if we have a look at our build, you can see that the camera control is pointing to the main camera, which has that object, and the animator is pointing to Douglas himself. Okay, so really simple script. So what we've got here so far are a few public methods on the director and a JavaScript call whenever an animation changes event. So what I'm going to do now is quickly jump over to the Angular code. And if you followed through the first tutorial, you should have a component which has a home component, and we created a Unity component that loaded the game instance. So this is just a really quick recap. So in our Angular, find the Unity loader. There you go. So you'll see in our build we have a script that loads the Unity loader. We also made some slight changes to the Unity loader in that first tutorial to remove any mobile warnings, so that we can run fine on a mobile without any issues. So we've kept that Unity loader, we've not made any changes. What I have done since the first tutorial is previously that was in a folder called build. So we put the exported build. So if I go to this now, open up the build menu, not this, sorry, Unity, and open up the build menu, you'll see I have it set to WebGL. When I press build, I'm exporting it to a folder called Craig Gilchrist Unity, and then I copy that into the build folder here. Previously that was just called a folder called /assets/build. What I've done is I've added an extra component called part2, and I've slightly changed the Unity component within that. So if I have a quick look at the old component, we had this Unity component. What I've added is a new attribute to this. So we now have a new input property, which is the version number. And all the major change in this one, all I've done is I've added the version number into the path. So now we have both versions. We have our first tutorial, which is this here, which is the 3D model of me, and we have now the second build. And so the build for this is in assets/build2, and the build for the first tutorial is now in a folder called build1, where previously it was in just a folder called build. And that's what the version input does. So if we have a quick look at the 2 pages, so this was the original tutorial, so I've added the attribute version 1, and now the new tutorial, the Unity build itself, which is here somewhere. There you go. Let me just break that out into a new column so we can see. We now have version 2. So when the Unity build itself loads the game instance from the Unity loader, it will use the version number in the path, which corresponds to the assets directory. So the only other major change I've made to this is these 3 methods. So these 3 methods correspond to the methods that are on our director script. So we remember we had the start stop rotating. Let's actually quickly jump over. We have stop rotating, which corresponds to this method. Stop animation and set distance. So when you call, if you want to call any method from JavaScript to the Unity build, it's very easy to do, because you just call the send message method on the game instance, passing in up to 3 parameters. So the first one is the name of the object, which is director, and if I go to our scene, you can see that the object here is called director. The second thing is the name of the method, which our method is on this screen control script. So it's the stop rotating. And the third thing are any parameters to pass to the method itself. So you can see that the only different one is this distance, which accepts the distance value. So the distance gets passed there. So we've got the name of the object, the name of the method, and any parameters. So we've got, in this Unity component now, we've got three simple methods that will pipe through the command all the way back through to Unity. Sorry, the Unity game instance itself. Okay, so the final piece now to pull all of this together, if I have a quick look at the part 2, which is our page, just a very quick look at the app module itself, because all I've done is I've added a new path to the existing build called part 2, which is the part 2 component. So the part 2 component, let's have a quick look at the code. So this one is slightly different in that we have a view child reference to our Unity component itself. So the Unity component just has this div, shows the progress bar. In fact, if I reload version, the first tutorial, you'll see this is the page itself, and then the progress bar that you saw briefly for a second there, and the container div for the build are part of the Unity component. The rest of this content, the hello Unity and the text and everything, that's part of the page. So our new tutorial is the same. However, we've got this extra column. I'm just using the default Bootstrap SaaS packages that come with the standard Angular app template in Visual Studio. So what we've got is these extra set of controls, and I'm going to briefly go through these controls. And the same Unity component here. So if I was to reload this one, it takes a little while, this one, but you can see that same loading bar, and then the container here, and the canvas. So this one's slightly different in that, sorry, the part 2 component slightly different in that the Unity element we have named and we are referencing as a view child. And the reason we're doing that is so that we can call methods on it. So if I open up the part 2 component, you'll see that we set the progress, we call the stop those 3 methods that pipe back through to JavaScript. The final piece to the puzzle here is that we have, if you recall back to the jslib folder, jslib file, that's doing a check to see if the window animation change listener event function exists, and it's passing the message through that when the animation changes state. So in our part 2 component in ng on init, we set that function, accepting the animation name, and we set that as a local property when that occurs. So that's the first part there. If I open up the HTML alongside it. I don't know if this view's a little bit busy, but so what we've got is a property called animation name, which we set as a default as unknown. If I reload this, you'll see for a second while it's loading that it says unknown, and then immediately the method is called out and says idle. And if I have a look at if I inspect, and see that we still get the debug animation name changed idle. We still get the debug information from our Unity build as well. Okay, so I'm setting the value every time this animation change. So I'm creating a function called animation change listener on the window, and in that function I'm setting the local components property name to the animation name that's passed to it. So if we now have a quick look at the view for that, we have a paragraph, a couple of things. We've got an ng container if it's loaded, which has this ng if Unity is loaded, and what we're doing with that is we're taking the Unity property. Once the progress equals 1, we are assuming the Unity. So we've got this getter that just basically checks to see if Unity progress is 1, and if it is, then Unity is loaded is true. Otherwise, we've got this ng template called loading, and that just shows the progress, and the progress is a getter as well. And what it does, the progress itself is a float value, obviously between 0 and 1. So all it's doing is just making it a nice simple number. It's a bit glitchy. You only ever seem to get 30, 60, and 90%, and then loaded. You don't really get any sort of more granular loading from the Unity loader. You see that? If I reload again, you get 30, 60, 90, and then loaded. So while it's loading, you get the word loading. Otherwise, you get this panel. And the first part of that panel is just a paragraph that says current animation, and we are referencing the animation name. So the animation is going through. We've got our animation events, animator events, which is checking the actual animator within the Unity build, passing it through to the animation state changed imported external void, which comes from our JSLib file. And that JSLib, that method itself, animation state change, is then checking to see if the animation change listener exists on the window element of the DOM, and it's passing the string that was passed all the way through to that. And then over in Unity, we've got we are setting that animation change listener name, change listener function, and we're setting that to a local property on the component, which we're then referencing in markup. And the effect is this. So we get our little badge. Okay. So that's output from Unity, the Unity WebGL window, through to a method in the DOM on window that we've added to window, which then we are taking the property that's passed to that method and we're popping it into our component and then referencing it in our view. Then secondly, what we've got, if you remember, on the Unity component itself, we had those 3 methods that send a message to our game instance. So send function calls to our director of start stop rotation, start stop animation, and set distance. And what we've got is in the component itself, we've got a few buttons. So we've got the first button, which is which calls start stop animation on the part 2 component, which in turn pipes it through to our Unity view child. So that's, so when I click this button, it calls the start stop animation method on the part 2 component, which calls it on the Unity component, which is the container itself. Sorry, the game instance itself, which sorry, the Unity component, which sends a message to the game instance object called director, and it sends that message all the way through. So these two are pretty much the same thing, just a simple send message on the director, and then the final one sends through the value. So we've got, if I look at the code, we've got set camera distance 1, 5, 10, and 20, which is does exactly the same thing. So set camera distance on the part 2 component, and if I go to the definition of this in the Unity one, you'll see that that just sends a message to the game instance passing through the value as the parameter. So as I'm rotating, you can see that's 1 meter distance, 5 meters, 10 meters, and 20 meters from the object. And that's it. Like I said, it was going to be a really quick tutorial. We've been going half an hour, but this is two-way communication between an Angular, a WebGL, Angular .NET Core hosted application. So yeah, if you have any questions, just drop me a line on Twitter. I'll also post the code and a couple of steps through to this on my website, and the full code for this for the build is available on GitHub. So yeah, hope you've enjoyed this and look forward to seeing you soon.